All right, so welcome to today's kind of study session video thing. Today we're doing systems of equations. Whenever the next question pops up, I recommend you guys to just pause the video, try the question out for yourself and see how that goes. And then you can resume the video and we can kind of compare how we do the question and see if we get the same answer, okay? So let's start with question A, shall we? Now, notice these are both kind of neither of them are in functional form. So since, neither of them have an isolated variable, let's try using an elimination method, all right? So we've got x plus y equals 10. And we've got 2x plus 2y equals 2. So to make the coefficients match up here, let's multiply this top equation by 2. Okay, remember it's the whole thing by 2, all right? Not just the left side. So this can give me 2x plus 2y equals 20. And then here we're going to have 2x plus 2y equals 2. And now we can subtract here, okay? And so 2x minus 2x is just going to be 0. And 2y minus 2y is just going to be 0. And 20 minus 2 is going to be equal to 18. So we get 0 is equal to 18, and this is false. So in this case, this has no solutions. Okay. Let's look at question B then. So 2x plus 3y equals 12, and x equals 1 plus y. So in this case, we already have one of these variables isolated, but not in both equations, right? We don't have two functional forms, you just have one. So we could just take this, okay, this 1 plus y here, right? And we know because x is equal to that, we can just kind of sub this into here, right? Right here, okay? So you're going to get 2 times 1 plus y plus 3y is equal to 12. And now we rainbow method this. You're going to get 2 plus 2y plus 3y is equal to 12. Okay. Simplifying this a little bit, you get 2 plus 5y is equal to 12. We minus 2 on both sides. We get 5y is equal to 10. Divide both sides by 5. You get y is equal to 2. And now to find what x is, you just take this y equals 2 and plug it back into either one of these equations. I think this right one is a little nicer. So let's just plug that back in. You get x is equal to 1 plus 2, which is 3. So x is equal to 3. Your final answer then is just 3, 2. Okay. Question C over here. So we have two equations. Both are written in functional form. So we can use comparison method here. Okay, so let's just make this right side of this equation equal to this right side here. Okay, so we got minus 3x minus 12 is equal to minus 2x plus 11. Let's bring all of our x's to the left and all of the constants or these numbers here to the right. Okay, so we have minus 3x plus 2x is equal to 11 plus 12. So here we're going to get minus 3 plus 2 is just minus 1x, so minus x. And 11 plus 12, that's going to be 23. Okay, and so now we divide both sides by minus 1. X is equal to negative 23. And to find out what y is, we just have to take this and plug it back into either equation. Let's use the right one here. We have y is equal to minus 2 times minus 23 plus 11. So y is equal to positive 46 plus 11. Y is equal to 57. So your final answer then is minus 23 and 57. All right. Now on to question D. So over here. All right, we've got this equation. That's not in functional form. Nothing's really isolated here. But here we have y equals x minus 2. This is in functional form. We have this y isolated, so we can use substitution method, right? One of my equations has a isolated variable. Now I know y is equal to x minus 2. Let me use a different color here. Y is equal to x minus 2. Okay, so I could just plug that x minus 2 into there. Okay? So you're going to get 4x plus 5, and instead of y, I'm going to write x minus 2 is equal to 20. Now we distribute that 5, right? We get 4x plus 5x minus 10 is equal to 20. We simplify this a little bit. You get 9x is equal to 20 plus 10. That's going to be 30. And now if we divide both sides by 9, you're going to get x is equal to 30 over 9, which simplifies to 10 over 3. All right. Now, if you want to find what y is, you just have to plug this back into either one of these equations. I think we all agree that this right one will work a little nicer. So y is equal to 10 over 3 minus 2, right? And so y is equal to 10 over 3. Let's put this over 3, okay? So we multiply the top by 3, multiply the bottom by 3. You're going to get 6 over 3. So now we have a common denominator here. 10 minus 6 is just going to be 4 over 3. So your final answer is 10 over 3, 4 over 3. All right. Now on to question E. Okay. So in this case, we have two equations. In both cases, neither of the variables are isolated. So let's use elimination method then. We have x plus 2y is equal to 8, and we've got 6x minus 2y is equal to 10. So to make the variables match up here, let's multiply this top one by minus 1, okay? So that's going to give me minus x minus 2y is equal to minus 8. And underneath, we're going to have 6x minus 2y is equal to 10. Now we're going to subtract the equations. So minus x minus 6x, that's minus 7x. Minus 2y minus 2y is going to be 0. And minus 8 minus 10 is minus 18. And so you're going to be left with minus 7x is equal to minus 18. So x is equal to minus 18 over minus 7, right? And luckily, that cancels out nicely. The negatives cancel out nicely. You're going to get 18 over 7. Unfortunately, the numbers don't work out nearly as nicely, okay? Now, to find out what your y is, you have to take 18 over 7 and plug it back into either one of those equations, okay? So let's use the left one here, all right? So we're going to get 18 over 7 plus 2y is equal to 8. So 2y is equal to 8 minus 18 over 7. Let's put this on a common denominator here. So multiply by 7, multiply by 7. Okay, you're going to get 2y is equal to 56 over 7 minus 18 over 7. Okay, and so 2y is equal to 56 minus 18. That's going to be 38 over 7. And if you divide both sides by 2, you're going to get y is equal to 19 over 7. So your final answer then, I'll write it on the left here, is 18 over 7, 19 over 7. All right. So next question here, F. Now once again, we don't have any isolated variables, so we're going to use elimination method. So let's write this out real quick. 3x minus 3y is equal to 12. And we've got 2x plus 2y is equal to 20. Now to make the coefficients for x match over here, I'm going to multiply the top equation by 2 and the bottom equation by 3. And so that's going to give me 6x minus 6y is equal to 24. And my bottom equation here, I'm going to get 6x plus 6y is equal to 60. And now we just have to subtract the equations. So 6x minus 6x, that's 0, minus 6y minus 6y, that's minus 12y. And 24 minus 60, that's negative 36. And so now we have minus 12y equals negative 36. We just have to divide both sides by negative 12, which leaves me with y is equal to positive 3. Okay, now to find out what x is, I'm going to take this, y equals 3, I'm going to plug it back into one of my equations. Let's use the second one here. So we're going to have 2x plus 2 times 3 is equal to 20, or 2x plus 6 is equal to 20. So we minus both sides by 6, we get 2x is equal to 14, so x is equal to 7. So your final answer then is 7, 3. All right. Let's go down over here to G. Okay. So we've got 2x plus y equals 7 and 5x minus 5y equals 15. Again, none of my variables are isolated, so I'm going to use elimination method. We've got 2x plus y equals 7 and 5x minus 5y equals 15. Seems like the easier one to match in this case would be my coefficients for y. So I'm going to multiply my top equation by minus 5. And so that's going to give me 10x minus 5y is equal to minus 35. And underneath, I still have 5x minus 5y is equal to 15. And now I'm just going to subtract my equations here. So minus 10x minus 5y, that's minus 15x. Did I say y? Minus 10x minus 5x is negative 15x. Now the y's are going to cancel out, so they're going to be plus 0. And minus 35 minus 15, that's going to come out to minus 50. Now we divide both sides by negative 15. That's going to give me x is equal to minus 50 over negative 15. The negative signs cancel out here. And 50 divided by 15, that simplifies to 10 over 3. Okay. Now, to find what y is, I'm just going to take this x equals 10 over 3 and plug it back into one of my equations. I think that left one looks a little nicer right now. So 2 times 10 over 3 plus y equals 7. 20 over 3 plus y equals 7. So y is equal to 7 minus 20 over 3. Let's put this on a common denominator here. Okay, so we multiply the top by 3, the bottom by 3. And so that's going to be 21 over 3 minus 20 over 3. That's just going to be 1 over 3. Okay, so my final answer then is 10 over 3, 1 over 3. Okay. Now, let's look at question H over here. So we've got two functions that are in functional form. So that's nice. We can just use comparison method. Okay, we're going to compare this to this over here. So we've got minus x plus 12 is equal to x minus 1. Okay, let's bring the x's to the right and bring my constants to the left here. So I'm going to get 12 plus 1 is equal to x plus x. Okay, this is 13, this is 2x. So 6.5 is equal to x. And now to find what y is, I'll plug this 6.5 back into one of my equations. I think this right one looks a little nicer. So 6.5 minus 1 is just 5.5. So your final answer is 6.5, 5.5. Now, question I over here. So this one, there's no isolated variables, but there is on this side, so we can use substitution, right? I know x is equal to minus 2y plus 4, so I can just replace this x over here with this guy, okay? This goes a little off screen. Let me show you the whole arrow. Okay, we've got this. Okay, we can plug this thing into there. All right. So let's write that out. We've got 5 times minus 2y plus 4 minus 3y is equal to 9. Now we're going to rainbow method this. We're going to get minus 10y plus 20 minus 3y is equal to 9. So minus 13y plus 20 is equal to 9. Let's subtract 20 from both sides. You get minus 13y is equal to negative 11. So y is equal to negative 11 over negative 13. The negatives cancel out here. So you're just left with y equals positive 11 over 13. And now to find what x is, we'll just plug 11 over 13 into this equation on the right. So x is equal to minus 2 times 11 over 13 plus 4, which comes out to negative 22 over 13 plus, and then here, let's put this all on a common denominator. So we multiply the top by 13, the bottom by 13. And on top, you're going to get 52. And on the bottom, you still have 13. So now we just do 52 minus 22. That's just going to come out to 30 over 13. So your final answer then, okay, x is equal to 20 over 13. So you have 30 over 13, and 11 over 13. Okay. Now on to question J. So here we have no isolated variables, so we can just use elimination method again, I guess. Okay, so 2x plus 3y is equal to 6. For x minus y is equal to 5. So to make, let's say, the coefficients for my x match here, I'm going to multiply the top equation by 2. So that's going to give me on top, I'm going to have 4x plus 6y is equal to 12. And my second equation looks like this still. All right. Now we're all set to subtract the equations, right? So 4x minus 4x, that's going to come out to 0. 6y minus y, that's going to be 7y. And 12 minus 5, that's just 7. So divide both sides by 7, you get y is equal to 1. Now we're going to take this y equals 1, plug it back into one of my two equations. Let's use the right one for now. So we've got 4x minus 1 is equal to 5. Add 1 to both sides, you're going to get 4x is equal to 6. And so x is equal to 6 over 4, which reduces to 3 over 2. So your final answer then is 3 over 2 and 1. Next up here, we've got question K. All right. Okay, so I feel like we've been doing a lot of elimination method for these types of questions where there's no isolated variables. And not to say that that's wrong, you can still use elimination method for this question, and in fact, I would encourage you to. But just in case, you feel more comfortable with substitution method, I want to show you that you could still use that in this question. All you have to do is just isolate one of your variables, which you can do really easily with this left-hand side equation here, right? So we just have to push that 4y to the other side, okay? Or subtract 4y from both sides. You're going to get x is equal to minus 4y plus 14, right? And now, knowing that x is equal to minus 4y plus 14, you can take this and substitute it into this x, okay? So instead, in the place of this x, we're going to write minus 4y plus 14. So you're going to get 3 times minus 4y plus 14 minus 2y is equal to 1. And now we're going to rainbow method here, distribute that 3. You're going to get minus 12y plus 42 minus 2y is equal to 1. Minus 14y is equal to, and we subtract 42 from both sides, you're going to get negative 41. And so y is equal to, now it's going to be positive 41 over 14, right? And unfortunately, this doesn't really reduce very much anyway. Now, we just have to plug in this y equals 41 back to find what x is equal to. So we know x is equal to minus 4y plus 14. Let's plug it into there. So x is equal to minus 4 times 41 over 14 plus 14. Okay, and so x is equal to, this is going to come out to negative 164 over 14, okay? And here I'm just going to do, well, we have to put this on a common denominator here, right? So here we've got times 14. At the bottom we have times 14. And so on top we're going to have 196 divided by 14, right? And so now, since this is on a common denominator here, we can just subtract the top. You're going to get minus, well, not minus, positive 32 over 14. And this reduces to 16 over 7. Okay, so your final answer then is 16 over 7 and 41 over 14. Okay, now let's look at L over here. So here now we're doing semi-linear systems of equations. So here we've got a quadratic, here we've got a line. So let's just set them equal to each other. So we've got x squared minus 4x plus 1 is equal to 2x plus 8, right? We're going to make the expression of x equal to each other. Okay, forget about the y's for a second. All right, let's bring it all to one side. So that one of the sides of my equation is just going to be equal to 0. Okay, so let's bring everything to the left. We've got x squared minus 4x plus 1 minus 2x minus 8. And now the right side is just 0, which is what we wanted. Okay, let's group up some like terms here. So we've got these terms here with an x, right? And here we have the constants. Okay, so we're going to have x squared minus 6x minus 7 is equal to 0. We can use sum and product here. What multiplies out to minus 7 but adds up to minus 6? Well, we've got minus 7 and we've got positive 1, right? So we can just write x minus 7 and x plus 1 is equal to 0. And now we can use the zero product rule, right? If these two things multiply out to 0, then one of these two have to be equal to 0. And when is that going to happen? Well, x equals 7, and when x is equal to minus 1. Okay, so we have x1 and we have x2. We have two solutions. So let's find the corresponding y's to each of these solutions. Let's plug it back into this rule over here. So y1 is going to be equal to 2 times x1, which is 7, okay, plus 8, which is going to be 14 plus 8. That's going to come out to 22. And y2 is going to be 2 times minus 1 plus 8, which is going to come out to minus 2 plus 8, which is just going to be equal to 6. So my two solutions are 7, 22, and minus 1, 6. Okay. All right, so let's take a look at question M. Okay, so once again, we have a semi-linear system of equations. Let's make these equal to each other, okay? So we've got 4x squared minus 5x plus 2, and that's going to be equal to minus 3x plus 8. Now we're going to bring everything to one side again, so that one side is going to be equal to 0. So we're going to get 4x squared minus 5x plus 2 plus 3x minus 8, and that's going to be equal to 0. Now let's group up some like terms here. We've got minus 5x and positive 3x here, so that's going to come out to minus 2x. And here we have a plus 2 and a minus 8. That's going to come out to minus 6 equals 0. Okay, now see this coefficient here is not a coefficient of 1. So when we do sum and product, we're not asking what multiplies out to minus 6 and adds up to minus 2. We actually have to multiply this 4 and the minus 6. So now we're asking what multiplies out to minus 24 but adds up to minus 2, right? And the answer to that question is just going to be 4 and minus 6, right? So we've got 4x squared plus 4x minus 6x minus 6, and that's going to be equal to 0. Okay, we split up this into two different terms. Now we can group up these two terms by just factor out a 4x. Here we have 4x plus 1. And these two terms, we can factor out a minus 6. That's going to be x plus 1. And now we can just do some grouping here to finish this off. We got 4x, oh, I forgot 0. 4x minus 6 is equal to, times x plus 1 is equal to 0. Okay? And once again, we can use the zero product rule here, right? If these two things multiply out to 0, then one of them has to be equal to 0. And when is that going to happen? Well, for this one, that's going to be when x is equal to positive 6 over 4, right? X equals 6 over 4, or 3 over 2, okay? And for this one, that's just x equals minus 1, all right? So we've got x1, we've got x2. Once again, we have two different solutions. Now, to find out what my corresponding y's are, we're going to take these x's and plug them back into this equation over here. So y1 is going to be equal to minus 3 times 3 over 2 plus 8, okay, which is going to come out to minus 9 over 2 plus, and now we can kind of put this on a common denominator here. We multiply the top by 2, the bottom by 2. You're going to get 16 over 2. And now that these two are on common denominators, we can just add the numerators together. That's going to be 7 over 2. Now for my second solution here, we've got x2 equals minus 1. So we've got minus 3 times minus 1 plus 8. Okay, this multiplies out to positive 3 plus 8, which is just going to give you 11. So my first solution then is 3 over 2, 7 over 2. And my second solution is going to be negative 1 and 11. All right. Now, let's look at this question over here, question N. All right, similar question here. We got quadratic and we've got a line, and this one does not have a coefficient of just 1. All right, so let's do the same exact thing here. We're going to take this and make it equal to this. Okay, so we've got minus 2x squared minus 5x plus 6 is equal to minus 2x plus 4. Let's bring everything to the left side, so one of my sides is just 0. So minus 2x squared minus 5x plus 6 plus 2x minus 4 is all equal to 0. Now we group up our like terms here. Minus 5x plus 2x, that's just going to be minus 3x. 6 minus 4, that's just 2, equals 0. Okay, now the question is, what multiplies out to minus 4, right? Because we're taking this minus 2 times this 2. So what multiplies out to minus 4, but adds up to minus 3? And the answer to that is minus 3 and 1. So we're going to split this middle term here into a minus 4x and a 1x, or I'm just going to write x, okay? And now here are these two terms. We can factor out a minus 2x. So here we're just going to have x plus 2. And then here I'll just like put these brackets here, x plus 2 equals 0. Okay, we can also say this is like 1 times x plus 2. So now we can group these terms, right? Minus 2x plus 1 times x plus 2 equals 0. Okay, now once again, you have your zero product rule, right? If these two things multiply out to 0, one of these has to be equal to 0. So when does that happen? It's when this one is equal to 1/2. So x1 is equal to 1/2, and x2 is equal to minus 2. So we have my two solutions for x here, but we still have to find out what y is. So let's plug these back into, let's say, this equation here, this right one. So y1 is equal to minus 2 times 1/2 plus 4. Okay, that's going to come out to minus 1 plus 4, or 3. Okay, and y2 is equal to minus 2 times minus 2 plus 4. That's going to be positive 4 plus 4, and that's equal to 8. So my first solution then is 1/2, 3, and my second solution is minus 2 and 8. Okay. And last but not least here, question O. All right, so once again, let's just make this equal to this guy over here. All right, So we've got minus 4x squared minus 3x plus 6, and that's going to be equal to minus 8x plus 1. Let's bring everything over to that left side so that one of the sides of my equation is just equal to 0. So we've got minus 4x squared minus 3x plus 6, and now we've got plus 8x minus 1, and that's all equal to 0. All right, now let's combine my like terms here. Okay, we start with this for negative 4x squared. Okay, minus 3x plus 8x, that's plus 5x. And 6 minus 1, that's just 5 equals 0. Once again, this coefficient here is not equal to 1. So let's multiply it to that last term here. That's going to be minus 20. Now we're asking ourselves, what multiplies out to minus 20 but adds up to positive 5? And I mean, it's not exactly obvious. Okay, so let's use the quadratic formula. If you don't remember, I'll write it on the screen here. We have x is equal to minus b plus minus the square root of b squared minus 4ac, all divided by 2a, all right? And this coefficient right here, that's your a. This coefficient right here, that's your b. And that constant term, that's c, okay? So if we plug that in, then we're going to get x is equal to minus positive 5, that's just minus 5, plus or minus the square root of b squared, that's 25, right? 5 squared is 25, minus 4 times a, which is minus 4, times c, that's just positive 5, divided by 2 times minus 4. Okay? So x then is equal to minus 5 plus or minus the square root of 25. Here we've got minus 4 times minus 4, that's positive 16, times 5, that's plus 80, divided by minus 8. Okay? And that's going to be equal to minus 5 plus or minus the square root of 105 divided by minus 8. All right? So my first x then, right, x is going to be equal to, x1 is going to be equal to, if I punch this into my calculator real quick, that's going to come out to minus 0.656. And my second solution here is going to be equal to 1.906. Okay, and now to find the corresponding y's, we just have to plug it back into one of my equations. Let's use, I think it was this one. Okay, I think it was minus 8x plus 1. So if we plug x1 back into this, we're going to get y1 is equal to 6.25, let's just round that, 6.25, and y2, that's going to come out to minus 14.25. Okay, so your two solutions then are minus 0.656 and 6.25, and 1.906 and negative 14.25. So those are your 2 points of intersection. Okay, so that's going to wrap it up for today's study session video. Let me know if you have any comments, any questions, and if you have another topic that you want to do a study session for, just let me know in the comments below, okay? Yeah, have a good one. Bye.